Hello dear student, welcome to my new physics channel PhysicsJN, that is for special for joint and NEET. इससे पहले मेरा चैनल था टॉकिंग फिजिक्स विद पियास सरकार, बट ड्यू टू सम रीजन वी कैन नॉट कंटिन्यू विद दैट. सो ये मेरा चैनल है. तो आज से आप लोगों का सर दैट इज पुष्परंजन सरकार मैं आप लोगों को फिर से एक बार फिजिक्स पढ़ाने आया हूँ. तो अगर आप लोग को मेरा वीडियो अच्छा लगे तो मेरा चैनल जरूर सब्सक्राइब करिए, लाइक करिए. मैं आप लोगों का टोटली फिजिक्स का जो 11-12 पर चैप्टर का जो न्यूमेरिकल्स है, थ्योरी है, वो विथ नीट एंड जॉइंट, मेंस एंड एडवांस, सो थ्रू आउट में आपको सिखाऊंगा. ओके, सो विदाउट लेट we will start our today topics, that is Biot Savart law. Now we will deal with some magnetic effects. So we deal with the magnetostatics at first. What is Biot Savart law? Now हम लोग सब जानते हैं कि किसी भी अगर वायर से कोई करंट पास होता है तो उसके अराउंड में क्या होता है, मैग्नेटिक फील्ड क्रिएट होता है. उसके अराउंड में मैग्नेटिक फील्ड क्रिएट होता है. तो आज तक हमने ये जाना था कि ये मैग्नेटिक फील्ड कैसे होता है, कि इसका जो कॉन्सिक्वेंस है. अगर साइंटिस्ट ओरेस्टेड ने हमको बताया कि अगर हम कोई भी मैग्नेट को इस वायर के नीचे या ऊपर रखें तो ये क्या होता है, डिफ्लेक्ट होता है. सो दिस इज ओरेस्टेड एक्सपेरिमेंट. This is the Oersted experiment. OE, that is Oersted experiment. But today we know the magnitude of magnetic field or magnetic induction due to some current carrying wire. So if we take a small segment or a wire of XY, and if current I goes through it or passing through it, then at some any arbitrary point P, we should find out the value of magnetic field. Magnetic field is notation is B. This is called magnetic field. Magnetic field और इसको हम कहते हैं magnetic flux density. Magnetic flux density, or more appropriate is magnetic induction. Magnetic induction is more technical term. So if a current passes through the wire XY, then it creates a magnetic field around its neighborhood medium. So what will be the magnitude of magnetic flux density or magnetic induction at point P? We can find out this by using Biot Savart law, which tells us that if we take a small arbitrary element called dl, then due to this small element we can first find out the magnetic field at point P. Then we integrate the whole wire within a certain limit or as per the shape of the wire to find out the total magnetic field density at P. So if we take a small length element dl, and if the direction of current makes an angle theta with a position vector r. R is the position vector between the current segment or the small element dl. Dl is called elemental length, elemental segment or elemental length. So if the elemental segment dl or the direction of current makes any arbitrary angle theta with the position vector r, that is the line joining between the point P and the element, then it can be proved that the magnetic induction dB for the elemental and dl is proportional to current I, number 1. Number 2 is dB is proportional to elemental segment or elemental length dl. Number 3, dB is inversely proportional to the area of the distance between the elemental segment and the point P. And number 4, dB is proportional to the angle of the sign between the direction of current and the position vector or the line joining the element and P. So if we take these 4 terms together, then we can find out that dB is proportional to I dl sin theta divided by r square. So dB, if we omit the proportionality constant sign, so you can get a constant which is known as k into I dl sin of theta divided by r square. Now k is a proportionality constant. The value of k is mu0 divided by 4 pi, that is 10 to the power minus 7 Tesla meter ampere minus 1. Okay, so the Biot Savart law is dB equal to, therefore the Biot Savart law dB is equal to mu0 by 4 pi I dl sin theta divided by r square. This is the scalar form of Biot Savart law. But this dB is the only magnetic field due to this element, dl element. Okay. So what is the total effect of the total by xy? So to find the total magnetic field, we should integrate the whole way within the certain limit. So B is equal to integration y to x or integration total mu0 by 4 pi I dl sin of theta by r square. So using Biot Savart law, we find the magnitude of magnetic induction at some certain point. Okay. Now, this is the scalar form of B. Now we go with the vector form of Biot Savart law. So, vector form of Biot Savart law. So we can know that dB is equal to mu naught by 4 pi into I dl sin of theta divided by r square. We can write it as mu0 by 4 pi I dl sin theta into r cap by r square. R cap is unit vector along the direction of magnetic field. So we can write as mu0 by 4 pi I dl sin theta vector r divided by r, that is r cube, because r cap is vector r by magnitude of r. We know that any unit vector is represented by its vector form divided by magnitude of this vector. So we can write as the vector form dB is equal to mu naught by 4 pi I dl cross r by r cube. Ideal cross r by r cube. Okay. Ideal cross r by r cube. dB is equal to mu naught by 4 pi ideal cross r by r cube. Here, if we take r and dl from the definition of cross product के डेफिनेशन से ये साफ मालूम होता है कि अगर कोई वेक्टर किसी का क्रॉस प्रोडक्ट है, अगर वी कैन से दैट a and B, two vectors, and if we take a right-handed screw and turn it from A to B, then the tip of the screw going along C. So here the vector C is perpendicular. C is equal to A cross B. So C is perpendicular to both A and B. So the magnetic field is perpendicular to both DL and R. But this is the only the magnitude of magnetic field. This is only the magnitude of B, that is magnetic flux density. How we can find out the direction of it? From this relation we cannot say the direction of magnetic field. So what is the direction of magnetic field? How can we find out it? So to find out the direction of B, we can say that the right and thumb rule. Right and thumb. What is this? If we hold a current carrying wire by the palm of our right hand, then the extended thumb gives, is along the direction of flow of current, then curl of our fingers gives the direction of magnetic field. If we hold a current carrying wire by the palm of our right hand, then extended thumb is along the direction of flow of current, then the curl of our fingers give the direction of magnetic field. इसका मतलब क्या है? So अगर मान लो कि ये एक करंट कैरिंग वायर है, इसके अंदर से आई करंट पास हो रहा है. So if we draw the thumb along the direction of current I, then the curl of our fingers if this is along the direction of current, our thumb represents the direction of current, then the curl of our fingers ऐसे curl होता है, gives the direction of magnetic field B. This is the right hand thumb rule. Okay, so अगर ये वायर है, ऐसे करंट जा रहा है, तो अगर हम अपना थंब को इन द डायरेक्शन ऑफ करंट लेते हैं, तो द कर्ल ऑफ आवर फिंगर गिव्स द डायरेक्शन ऑफ मैग्नेटिक फील्ड. सो Also, this is for the circular coils. If we take, इसको लिख लिया. So, if we take a circular coils, then if this is the direction of current, then the curl of our fingers, if this is the direction of current, then curl of our fingers, if we take direction of current and our thumb is extended along this, then the curl of our fingers, that is, gives the magnetic lines of the fields, direction of magnetic lines. So the direction of magnetic field is along the tangent of this magnetic field lines. Okay. Then the curl of our fingers gives the direction of magnetic field lines. This is the magnetic field lines. So magnetic field direction or flux density direction B is along the tangent of the magnetic field. And if we take this point as P and this point as Q, then what is the magnetic field at P and Q? So if we take our thumb along the direction of where, then at point B, if we take the curl of our finger, then it is along towards or inside the paper or into the paper. Then the direction of magnetic field is into the paper. So into the paper, we can write it as cross. If we take a cross, then the magnetic field is into the paper or inside the paper and perpendicular to paper. But for the Q, if we take the thumb in this direction, then if we curl our fingers, then this is the outside the paper. Okay, for outside the paper, we can take the sign dot. Okay, this is the direction of magnetic field into the paper, and this is the direction of magnetic field out to the paper, outside to the paper or plane of. Okay, I hope you give the direction from this. Now, this can be also stated by right hand palm rule. Right hand palm rule क्या होता है? Same direction. If we take that where and if we take the thumb, along the way and extend our palm to the point of application. If this is the point of application, then perpendicular vector of this palm gives the direction of magnetic field. So, but I tell you to remember right hand thumb rule or any screw rule, which is easily applied to make or to find out the direction of magnetic field. It is very easy. Okay. Now, what is the magnetic field और what is the application of Biot Savart law? Biot Savart law का application जो है वो 3-4 चीज निकालने में है. Magnetic field due to long straight wave, for finite and infinite wave, for a circular loop and Helmholtz coil. ये आपका सिलेबस में है. ओके. सो आज हम इसका जो फर्स्ट एप्लीकेशन है. Now we can find out the magnetic field due to an infinite wave. If we take a wave, suppose if we take a infinite wave from minus infinity to plus infinity, and we take only this portion of the wave and take a point O, from which at a perpendicular distance we take the point P at a distance R. We can find out the magnetic field at point P. So we take a small element dy at a distance y from O. So the position vector from y dy or dy to p is, this is root under r square plus y square. Okay. R is the perpendicular distance from point O to P, and from O at a distance y we can take a very small element dy. So this distance is r square plus y square. So from Biot Savart law we can find that dB equal to mu naught by 4 pi I here dy not dl I dy sin theta by r square. What is r here? This is r here. Root under r square plus cos. Okay, because r is the distance between p and the small element, not the perpendicular distance. Clear? So we can take the total value of b as from minus infinity to plus infinity mu naught by 4 pi I dy sin of theta divided by root under r square plus cos. Now take y equal to r tan theta. So you can get dy equal to r sec square theta d theta. And for y equal to minus infinity, theta becomes minus pi by 2, and y equal to plus infinity, theta becomes plus pi by 2. अगर आप लोग इंटीग्रेशन किया होगा तो आपको ये समझ में आ जाएगा. ओके, सो we can find out the total magnetic field B equal to B is mu naught I by 4 pi from minus pi by 2 to plus pi by 2 I is outside integral. Dy means r sec square theta d theta and sin theta. What is the value of sin theta? This angle is theta, so sin theta is perpendicular by hypotenuse. Okay, so r by root under r square plus y square. Okay, this is आइडियल में sin theta by r square, इसका स्क्वायर होगा या, so ये स्क्वायर नहीं जाएगा, r square plus y square, and then put the value of sin theta, then root under r square plus y square, that is we can get this value is r square plus y square to the power 3 by 2. Okay, okay, so we can get mu 0 I r square by 4 pi integration minus pi by 2 to plus pi by 2 sec square theta d theta divided by r square plus y square to the power 3 by 2. So if we take y equal to, we can take y equal to r tan theta, then y square equal to r tan square theta. So here we can get r square plus r square tan square theta to the power 3 by 2. Okay, now we can find out the value of b as mu naught I r square by 4 pi minus pi by 2 to plus pi by 2 sec square theta d theta divided by r square. अगर बाहर नहीं आता तो r square is outside the power, so this is r cube. 1 plus tan square theta is sec square theta. Sec square theta, so here is we can get that sec cube. Okay, so mu naught I r square divided by 4 pi r cube sec square theta or sec theta. So 1 by sec theta means cos theta minus pi by 2 to plus pi by 2 cos theta d theta. So here is r. So mu naught I by 4 pi r integration cos theta is sin theta, sin of theta from minus pi by 2 to plus pi by 2. So we can get mu naught I by 4 pi r. Sin pi by 2 means 1 minus 1, that is plus 1 2. So we can get mu naught I divided by 2 pi r. So the total value of B at a perpendicular distance from the wire is mu naught I by 2 pi r. And from the right hand thumb rule, you can also give the direction of magnetic field. So today we can learn about the Biot Savart law and also the application of Biot Savart law from infinite wave to make or to find out the magnetic field at a perpendicular distance from the infinite wave. So for today that is enough. In the next day we shall go with more application of Biot Savart law. So for today, thank you guys.